Welcome students. In previous class we have explained about some definitions, boiling point, melting point, and the relations and how state changes. Okay, so today as we have completed this chapter, so today we will discuss some exercise question, okay, from your book Selina publication. Okay. So here all questions and answers are available, but we will discuss some important question. Okay. So first question is the define the term calorie. Question 3, and how it related to joule. Calorie means amount of heat energy required to raise temperature 1 degree C of 1 gram of water, and actual definition is the heat required to raise temperature of 1 gram of water from 14.5 degree centigrade to 15.5 degree centigrade, because the amount of heat energy required from, let us say, 5 degree to 6 degree is not equal to the amount of heat required to increase temperature from 90 degree to 91 degree centigrade. Okay, these are different. At lower temperature region, amount of heat required to increase 1 degree temperature is not same in higher temperature region. Okay, so if we take average, that amount of heat required from 0 degree centigrade to 100 degree centigrade of 1 gram water, and we divide by 100, then the amount of heat required is nearly equal to the amount of heat required from 14.5 degree centigrade to 15.5 degree centigrade. Okay, so we may use, or we can use the definition that amount of heat required to increase temperature 14.5 degree to 15.5 degree centigrade of 1 gram of water. And we know the relation between calorie and joule, and 1 calorie equals to 4.186 or 4.2 joule. We can say 4.2 joule. Okay, near about. Define kilocalorie. Kilocalorie means 1000 calorie. We know. Define temperature and name it SI unit. We know temperature is the measurement of heat. Okay, and define the direction of flow of heat, temperature. It and the SI unit is Kelvin, not centigrade. Okay, you have to memorize or remember that SI unit of temperature is Kelvin. Difference between heat and temperature we have told. And next question is find the term heat capacity and state its SI unit. Heat capacity and specific heat capacity. Next question is specific heat capacity and its SI unit. Heat capacity is the amount of heat required to raise temperature 1 degree C, okay, or 1 Kelvin. We know 1 degree centigrade change equals to 1 Kelvin centigrade. Okay, it is heat capacity depends on mass. For large mass, large heat capacity, but specific heat capacity is the independent on mass. That means per unit mass. Okay, amount of heat required to increase temperature 1 degree C per unit mass. And another question is how heat capacity related to specific heat capacity. The heat capacity is the mass of specific heat capacity. Okay? Mass into specific heat capacity. Differentiate between heat capacity and specific heat capacity we have told. You can read. Next question is what is the value of specific heat capacity of water in SI unit? Most of the students answered wrong. It has 4200 joule per kg per Kelvin, not 1000. Okay, it is 4200 joule per kg. Now I know in SI unit amount of heat energy required per unit mass means per kg per 1 degree centigrade. So we know the specific CGS unit is 1 calorie gram inverse degree C inverse. So to convert, calorie is the 4.2 joule and per kg inverse, that means 1000 kg inverse. Okay, and joule kg inverse degree centigrade inverse. Next question is name 3 factors on which heat energy absorbed by body depends on the state How does it? Depends on them. We know the heat energy absorbed by the body H equals to, we know, m s delta T. That means H proportional to mass, proportional to specific heat capacity, and temperature difference. Okay, three factor is this: mass of the body, nature of the material of the body, rise in temperature of the body. Write the expression of the heat energy Q received by the substance of mass m and specific capacity C and heat through the point T degree. We know Q equals to ms delta T. Okay. So next question, you can study that why do the farmer fill their fields with cold winter with water on a cold winter night. Okay, to protect the plants from freezing. Okay. We know otherwise we know within when water start freezing, the volume of water increases, so it can destroy the plant, and so the veins will be burst due to increase of the volume of the water of freezing. Okay, vein of the plants will be burst. Water is used in hot water bottle for fermenting given region. You can study that water have high specific heat, so water is used for effective coolant for same region. Okay, we have studied. The next question is, what is calorimeter? Name the material which is made of. Give two region. The solution is, a calorimeter is a cylindrical vessel which is used to measure the amount of heat gained or lost by the body when it mixed with another body. Okay, it made up of thin copper sheet. Because copper is a good conductor of heat, so the vessel soon acquired the temperature its content. Okay. What is the principle of method of mixture or principle of calorimetry? This is an important question. Principle: heat gain equals to heat lost. Heat energy lost by the hot body equals to heat gain by the cold body. The question number 26 is a important problem. A mass m1 of substance specific heat capacity C1 and temperature T1 mixed with the mass m2 of other substance of specific heat capacity C2 at lowest temperature T2. Deduce the expression for the temperature of mixture. State the assumption made, if any. This is the, we have to find the temperature of mixture. That means hot body loss some heat, and this heat energy gained by the cold body, and then both reaches to a final temperature. Okay, so we have only one relation, that same relation, heat energy lost by hot body equals to heat energy gained by cold body. Okay, so if final temperature T, then heat energy lost by the hot body is this m1c1, 1 minute, m1c1 T minus T1 equals to heat gain by the cold body m2c2 T minus T2, and then we can find the temperature, final temperature, that m1c1 T1 plus m2c2 T2 by m1c1 plus m2c2. Yes. Next question is, now we will explain some numericals. Okay, so first question is, by imparting heat to a body, its temperature rises by 15 degrees centigrade. What is the corresponding rise in temperature in Kelvin scale? We know the change of centigrade scale equals to change of Kelvin scale. 1 degree centigrade change equals to 1 Kelvin change. So this 50 degree C will be 50 Kelvin. These are the very easy questions, you can see. Next question number 3 is, a piece of iron mass 2 kg has thermal capacity 966 joule per Kelvin. Find the heat energy needed to warm by 15 degrees centigrade. We know heat energy equal to thermal capacity into temperature. Then we can get, and specific heat capacity. Specific heat capacity is the thermal capacity per unit mass. That means 966 by 2. Okay. Then you can calculate. Question 5 is the same type question. You can see question 6. Find the time taken by a 500 watt heater to rise the temperature of 50 kg of material of specific heat capacity 960 joule per kg per Kelvin from 18 degrees C to 38 degrees C. Okay, assume that all heat energy supplied by the heater is given to the material. That means you can see, let us say a container or a material which is mass is 50 kg. Okay, this is heating by a heater or gas stove. You can, okay, I am taking heater. This is a heater. Okay, so this is heating by a heater. So the heater have 500 watt. That means 500 joule supplied by the heater per second. Okay, so how much amount of heat required we have to find. So at 50 kg material, okay, M is 50 kg, okay, and specific heat capacity is 960, and del T is this 38 minus 8. That means amount of heat required equals to ms del T, or M will be here mc del T written. So M is 50 kg, C is 960, del T will be 38 minus 18 equals to 20 degrees centigrade. Here written 50 into 960. That means amount of heat required, this amount of heat required. Okay, and heater producing 500 joule per second. So how much time required? Time required means amount of heat required by power. Okay, means amount of heat energy produced by the heater per second. So then we can get 1920 second means 32 minutes. Okay, this is important question. Question 7 is the same type question. You can, and solution is also here. Okay, question number 8. This is the same type question, that 0.5 kg of lemon squash at 30 degrees is placed in refrigerator, which can remove heat at an average rate 30 joule per second. Okay, so refrigerator can remove heat 30 joule per second. How long it will take to cool the lemon squash to 5 degrees centigrade? Okay, so how much heat can required to remove, we have to calculate. Okay, so amount of heat required to remove is 0.5 ms delta T, 0.5 into specific heat capacity of squash, then it is the specific heat capacity of water also, 4200 into 10 to the power mc delta. Delta means 30 minus 5. Okay, this amount of joule heat required, and this amount of heat is required to remove from lemon squash, and refrigerator can remove heat 30 joule per second. Okay, that means time required will be Q by 30, Q by P. That means 1750 second, that is 29 minutes 10 seconds. Okay, so these are the same type question. And B, in this part just we have to memorize most of the part. Okay. Sorry, we have to understand also. What do you understand by change of phase of the substance? Change of phase is one state to another state change. Solid to liquid, liquid to gas, these are the change of state. You can see the answer here. Next question is question number 6. State the effect of presence of impurity of the melting point of the ice. Give one use of it. The melting point of ice decrease by presence of impurity. If we mixed salt, normal salt with the ice, its temperature decreased to around minus 20 degrees centigrade. Okay, so uses it making the freezing mixture by adding salt in ice. Here is the example. The freezing mixture is used to prepare the ice cream. Okay. State the effect of pressure on the melting point. So with increasing pressure, the melting point is decreased for water or for ice. The melting point of ice decreased by 0.0072 degree for every 1 atmospheric rise in pressure. Okay. Question number 8 is, so the variation of temperature with time when some wax cooled from liquid phase to solid phase. So first in liquid phase the temperature decreases and with time, and then when it started to form solid, then its temperature become constant. When all the wax is converted to solid, then again its temperature started decreasing. Okay, this is the graph and this is the solution. This question we have discussed. What is the effect of increase in pressure on boiling point of the liquid? The boiling point of the liquid increases on increasing pressure. Okay. So in pressure cooker, the water boiled about 120 degrees C to 125 degrees. Question number 70. It is difficult to cook vegetable on hill or mountain. Explain why. On hill or mountain, there is the pressure is very low than the lower than the sea level. Okay, so the boiling point is low. Boiling point of water mainly is lower than the boiling point of the sea level. So water start boiling at low temperature. So the vegetable is not cooked properly. Okay. The answer is this is because at high altitude atmospheric pressure is low, therefore the boiling point of the water decreases, so it does not provide required heat energy for cooking. Okay. So then in this region we have to use pressure cooker. Okay. What do you understand by the term latent? We know. You can see the solution. Why do bottled soft drink get cooled more quickly by the ice cube than the ice water? Iced water. Iced water means water at 0 degree centigrade. Okay. We know the iced cube can absorb more heat because it has less heat energy. Means the 80 calorie per gram. Less heat energy have ice cube than ice water. Okay. So ice cube can absorb 80 calorie of heat energy to convert icy water. That means at constant temperature it can absorb more heat, but iced water cannot absorb heat at constant temperature. By absorbing heat, temperature of the water start increasing. Okay. So here is some more questions. You can see. Okay. Next class we will start on new chapter radioactivity. Okay. Thank you.